There is a bone in the male mammal body that can be as long as a baseball bat, and if you are male, you do not have one. It is called the baculum. A walrus has one that can reach 60 centimeters. A chimpanzee has a tiny splinter of one. Raccoons, bats, otters, and gorillas have one. The last common ancestor between you and a chimpanzee probably had one. But somewhere along the human lineage, evolution quietly removed it from the skeleton. The real mystery is not why some animals have a bone in the penis, it is why you lost yours. The first thing to understand is that the baculum is not doing what most people assume. An erection in mammals is still a hydraulic event. Blood fills the organ, pressure builds, and the tissue stiffens. The bone is not the source of rigidity. In fact, it floats in soft tissue, unattached to the rest of the skeleton. The name itself is almost too literal. Baculum means stick or staff in Latin, and in some animals, that is exactly what it looks like. It is one of the most variable bones in the mammal body. In some species, it is a simple rod. In others, it is curved, hooked, spiked, or flattened like a spoon. A walrus baculum looks like a club. A back baculum can be so elaborately shaped that scientists use it to tell species apart. In the Arctic, people have used walrus bacula as tools. The same body part that is missing in you has been turned into handles, clubs, and other objects. So if the penis already has a blood pressure system for becoming rigid, why add a bone? The answer starts to make sense when you look at what the bone actually does. It is not about getting hard. It is about staying inside. The baculum acts as internal scaffolding. It can support penetration before a full erection is reached, protect the urethra, and allow a male to remain inside a female for long periods without relying on constant arousal. A useful way to picture it is a tent. A tent can stand up with air pressure alone, but if you need it to stay up for hours, you want poles. The baculum is the pole. It takes over when blood pressure alone would be impractical. Different species have evolved that pole into different shapes because they face different sexual pressures. In dogs, it is long and slender, with a groove that cradles the urethra. In raccoons, it is curved. In walruses, it is massive. That variety is not random. It tells you that the baculum has been shaped by local reproductive conditions. And in many species, those conditions are intense. Sex in much of the animal kingdom is not a private bonding activity. It is a competition. If a female mates with multiple males, those males are not only competing to reach her first, they are competing after the fact. Inside the female reproductive tract, sperm from different males can be present at the same time. The question of paternity is not settled at ejaculation. One efficient strategy is to stay physically connected. A male that remains inside is blocking the doorway. He is delivering sperm and preventing rivals from doing the same. This is a form of mate guarding. But maintaining the physical state required for penetration can be demanding. Blood pressure alone may not be enough, especially over long durations. A bone gives the structure that the circulatory system no longer has to maintain. The baculum, in this view, is an endurance tool. That idea became much less speculative when researchers looked across species. They measured baculum length in primates and carnivores and compared it with mating behavior. The pattern was consistent. Species that copulate for longer tend to have longer bacula. Species with more intense post-mating sexual competition tend to have more prominent ones. Researchers are careful not to claim that the bone causes long mating. It is simply that the two have repeatedly evolved together. The fit is not perfect, but it is strong enough to be informative. Now consider humans. No baculum. That single absence is a clue. It suggests that human ancestors moved away from the strategy of prolonged, physically guarded mating. But this is not just a story about one missing bone. The human body carries several signs that the whole reproductive strategy changed. Human testes are smaller relative to body size than those of chimpanzees. In many primates, large testes are linked to high sperm competition. Males produce more sperm when females mate repeatedly with multiple males. Humans are not as extreme as chimpanzees, but we are not as relaxed as gorillas either. We sit somewhere in between. That is consistent with a mating system in which sperm competition became less intense but did not vanish entirely. Then there is ovulation. In many primates, females advertise when they are fertile. The external signs can be obvious. A male can focus his efforts on that window. But human ovulation is comparatively concealed. The timing is not obvious to others, or often to the woman herself. That changes the arithmetic of mate guarding. If you cannot tell exactly when a female is fertile, staying physically attached to her for a short fertile window does not work as well. The human lineage may have shifted toward repeated mating within a longer-term pair bond, rather than explosive competition during a visible estrus period. Pair bonding changes the reproductive bargain. If a male is investing in one female and his offspring, the immediate physical blocking of rivals becomes less central. Social relationships, cooperation, and female choice begin to matter more. That does not mean human mating became conflict-free. It means the selective pressures that built and maintained the baculum weakened. There is a broader pattern here. Humans show reduced male-male physical competition compared with some other apes. Male gorillas are much larger than females and have huge canine teeth, built for intimidating and fighting other males. Human males are not as dramatically different from females in size or tooth shape. That shift away from brute physical competition fits the same story. The human mating system became more social, more cooperative, and more dependent on female choice. But none of this means humans became a perfectly monogamous species. Human mating is famously varied. Infidelity, multiple partners, and complex non-monogamous arrangements have existed across cultures. The point is not that sperm competition disappeared. The point is that the specific physical tactic of blocking a mate with an internal bone became less central. Other forms of competition, social guarding, jealousy, status, sperm quality, were still in play. They just did not require a bone. A body part that is no longer useful can be lost in a surprisingly straightforward way. Mutations that disrupt its development are no longer harmful enough to be removed by selection. If the bone is not improving reproductive success, a mutation that shrinks it or stops it forming can spread by chance. There may even be a small advantage to losing it. Bones can break. They require energy to grow and maintain. Placed in a delicate organ, a bone is not entirely risk-free. In species where the baculum no longer helps, losing it may simply be cheaper. Evolution does not care about anatomical completeness. It cares about reproductive outcomes. This was not a dramatic moment in evolution. No fossil can show exactly when the human baculum disappeared because the bone is small and rarely preserves. It likely happened gradually after the human lineage split from the chimpanzee lineage. Some hominin populations may have had reduced versions, but the exact date matters less than the pattern. The human penis is already unusual in other ways. It has no spines. It is relatively large compared with those of other apes. These traits are not unconnected. Penile spines, like Bacula, are common in species with intense sperm competition. Their loss points in the same direction. Human ancestors were evolving away from a reproductive system built around physical competition between males. There is even a genetic clue to that shift. In humans, a non-coding piece of DNA near a gene called the androgen receptor is missing compared with chimpanzees and many other mammals. In those animals, that DNA region helps drive the development of penile spines. Its absence in humans helps explain why the human penis is smooth, where a chimpanzee's is spined. The baculum and penile spines are different structures, but they share an evolutionary context. Both are associated with high sperm competition and male-male sexual conflict. Both were lost as the human mating system changed. There is a strange irony here. We often think of evolution as adding things, as if becoming human meant gaining more sophisticated equipment. But the absence of a penis bone is not an upgrade. It is a reduction. It is evolution deleting a structure that no longer mattered. In fact, the human penis is an odd mix. It is larger in proportion to body size than a gorilla's, yet it has less internal hardware. It lacks the spines that many primates have. It lacks the bone that a walrus carries like a club. That mix makes sense only when you stop thinking of anatomy as a list of features and start seeing it as a record of behavior. Your body is not a finished design. It is an archive of what your ancestors did. A walrus needs a 60-centimeter baculum because its mating system is direct and competitive. A male must be able to mate quickly and effectively, and the bone helps. A human male relies on something less visible but more social: attraction, timing, cooperation, female choice. You do not have a penis bone because your ancestors stopped needing to win sex by physically blocking the competition. They were starting to win it differently. That is why the male human skeleton is one bone short, and why a walrus, for all its size, is carrying around a club in a place where the human male has nothing at all.